All right, welcome. Welcome, everyone, to the deep dive. Today, we've got this pretty hefty stack of sources, research papers, articles, and we're going to plunge right into a technology that, honestly, it didn't just upgrade our phones. It feels like it fundamentally reshaped, well, everything about our digital lives. We're talking 4G LTE.
That's right. It's easy to forget just how big a leap it was.
Totally. I mean, think back maybe, just over a decade ago? Using the internet on your phone? It wasn't quite the same experience, was it?
No, not at all. 3G networks, they were definitely the pioneers. They gave us those first apps, that initial taste of mobile browsing, which was amazing at the time.
It was. But you also remember the frustration, right? Waiting for videos to buffer.
Oh yeah, the buffering wheel, your nemesis.
Exactly. Or games lagging out, downloads taking forever. It just felt like this limited version of the real internet.
A mobile version, yeah.
Right. And I think people started wanting the full experience, without being tethered to Wi-Fi. That real hunger for proper speed on the go.
Yeah.
That's what set the stage for 4G.
And that's precisely our mission for this deep dive, digging into all of this material you've pulled together. We really want to dissect that shift. How did 4G actually leapfrog 3G? What were the core technologies that made it so much, well, faster and more reliable? And maybe more importantly, what are those profound effects? Sometimes surprising ones, actually, on everything from media consumption to, entire new industries popping up. We need to get past the marketing hype and pull out the really essential stuff.
Perfect. Sounds like a plan. So let's kick things off right at the beginning. Given that context, the limits of 3G, what was the main driving force behind developing 4G? What was its number one goal, and how did it specifically try to fix what 3G couldn't handle?
What's fascinating when you look at the sources, because the success of 3G itself, especially after the iPhone arrived and the App Store took off, it just created this, well, almost insatiable appetite for mobile data.
Right. Suddenly everyone wanted to do more on their phones.
Exactly. People had these powerful little computers in their pockets, and the demand for data-heavy, particularly video streaming, just absolutely exploded. It went through the roof. But the 3G networks, revolutionary as they were back then, they just couldn't keep up with that surge. They got congested really easily.
Yeah.
Which led straight back to those buffering issues you mentioned. Slow downloads, laggy online games.
Yeah.
The whole user experience started to feel compromised, didn't it?
It really did. It felt like we hit a ceiling.
We did. And the material we've got makes it crystal clear. The user expectation shifted. It wasn't just about wanting slightly faster mobile internet. People wanted the real deal, the kind of high-speed broadband experience they got at home, but, available everywhere on their phone.
So like parity with home broadband, basically.
Pretty much, yeah. That was the ambition. So the primary goal for 4G is really unambiguous. Build a network capable of low latency, that's the delay, the responsiveness, crucial for gaming and real-time stuff, and high throughput, meaning lots and lots of data moving really fast. And critically, it was designed from the ground up as a purely IP-based network. We'll probably talk more about that. But the whole point was to shatter those 3G limitations and deliver what the sources consistently call true mobile broadband.
True mobile broadband. Okay, that captures the ambition perfectly. So, moving from the why to the how, the sources really stress this big move towards a single global standard with 4G that was different from previous generations, wasn't it?
Oh, absolutely. A major shift.
What was this standard, and how did unifying around it impact the carriers, especially thinking about the Canadian context your material mentions?
Yeah, so back in the 2G days, and even carrying into 3G, you had these big competing standards, right? Like GSM versus CDMA. Different parts of the world, sometimes even different carriers in the same country, used fundamentally incompatible tech.
Right. I remember needing different phones sometimes.
Exactly. It created all this fragmentation. Roaming could be a nightmare. The massive shift with 4G was the widespread, almost universal adoption of one main standard, LTE, long-term evolution.
LTE.
And this was just a huge win-win.
Yeah.
For the carriers, it meant they finally had a clear, unified upgrade path. Didn't matter if their background was GSM or CDMA, LTE was the way forward. They could pool resources, invest in a single technology evolution.
Made things simpler for them, I guess.
Definitely. And the benefit for you, the user, was huge too. It meant true global interoperability becoming a reality. Your LTE phone suddenly worked reliably in way more places around the world. Roaming became much, much smoother. And focusing on Canada, like you asked, the sources point out that our major players, Bell, Rogers, TELUS, they didn't just dip their toes in. They invested heavily and quite early on in building up really robust nationwide LTE networks. These were just minor upgrades. They were foundational infrastructure projects.
So they went all in.
They really did.
Yeah.
And those networks were so successful and well-built that they later evolved pretty seamlessly into LTE Advanced, or LTEA, which pushed the speeds and the network efficiency even further. Canada actually got pretty good 4G coverage relatively quickly.
Okay, so one standard, simpler upgrades, better roaming. That definitely feels like progress. Now let's get into the nuts and bolts. What actually made 4G fast and efficient? The sources keep mentioning OFDMA as a cornerstone technology. Can you break that down? What is OFDMA and how did it help?
Right. OFDMA. It stands for Orthogonal Frequency Division Multiple Access. It's a really sophisticated radio access method at the core of 4G's air interface.
Okay. Orthogonal what now?
Yeah, it sounds complex, but think of it like this. Imagine the available radio spectrum, the airwaves carrying the signal, as a big highway. In older systems like 3G used WCDMA, it was kind of like assigning one user a pretty wide lane on that highway for a certain period.
One user, one big lane. Got it.
Exactly. Now, OFDMA is much smarter. It takes that entire highway and divides it into a huge number of very narrow parallel lanes. Think hundreds or even thousands of tiny lanes. We call these subcarriers.
Wow, okay. Lots of tiny lanes.
And here's the clever part. The network can then dynamically and flexibly allocate just the right number of these tiny lanes to many different users all at the same time. So if you just need a little bit of data, you get a few lanes. If you're streaming video, you get more lanes.
So it's much more tailored to what each person needs moment by moment.
Precisely.
Oh.
It's incredibly efficient at sharing the available bandwidth among lots of users simultaneously. Plus, there's another big benefit. Splitting the signal across all these narrow subcarriers makes the overall signal much more resilient to interference and things like multipath fading where signals bounce off buildings. This was a significant improvement over 3G, especially in challenging urban areas where signals get messy.
Okay, that makes sense. It's like optimizing traffic flow by giving everyone exactly the space they need on this massive multi-lane highway. Very cool. What about MIMO? That's another acronym that pops up constantly when talking about 4G speed. What does MIMO stand for and what did it do?
Right, MIMO. It's multiple input, multiple output. This one is all about using multiple antennas, but crucially, at both ends of the wireless connection.
Both ends, so tower and phone.
Exactly. You have multiple antennas on the cell tower transmitting the signal, and increasingly over the 4G era, multiple antennas packed inside your smartphone receiving it. You started seeing phone specs mention 2x2 MIMO, then 4x4 MIMO.
Yeah, I remember seeing those numbers.
So the core idea here is, instead of just sending a single stream of data between one antenna on the tower and one on the phone, MIMO techniques allow the system to send multiple independent data streams simultaneously over the very same radio channel.
Wait, multiple streams on the same channel. How does that work?
It uses clever signal processing and the spatial dimension created by the multiple antennas. Think of it maybe like sending several differently colored light beams through the same pipe. They travel together but can be separated at the other end. MIMO uses the spatial paths the signals take.
Okay, that's a bit mind-bending, but I get the outcome. More data at once.
Exactly. It dramatically increases the total data capacity, the throughput of that connection. That translates directly into those much higher peak speeds we saw with 4G, and as a bonus, it also helps improve signal reliability and coverage, especially indoors or in areas with lots of obstacles, because it can cleverly combine signals arriving via different paths.
So OFDMA is efficiently managing all the users on the network, and MIMO is boosting the speed for each individual user. They sound like a powerful combination.
They absolutely were key enablers for 4G performance.
Now, beyond the radio waves, the sources mention this fundamental architectural shift with 4G moving to an all-IP network. That sounds pretty foundational. What does all-IP really mean in terms of how the network actually operates?
Yeah, this was huge. Arguably the biggest change under the hood, the one that enabled almost everything else 4G delivered. You see, previous mobile networks, especially 3G, still carried legacy baggage from the old telephone network days. They had what's called a circuit switch domain, primarily for voice calls, running alongside a separate packet switch domain for data traffic.
Two separate systems, basically.
Kinda, yeah. They were interconnected but architecturally distinct. 4G threw that out. It was designed from scratch as a unified end-to-end packet-switched IP network. IP, Internet Protocol. The same fundamental technology that runs the Internet.
So just like the regular Internet, then?
Pretty much. In a 4G network, everything is treated as data packets. Your web browsing, your video stream, your app updates, your location data, and crucially, even your voice calls. It's all just packets of data flowing over the same IP infrastructure.
Okay, so no special path for voice anymore.
Nope. It's all data. This simplification, moving to a single, efficient IP core network, was a massive technical leap. It made the networks much more flexible, easier to scale up, and ultimately more cost-effective to build and manage compared to maintaining those older dual architectures.
Right, streamlining the whole operation. So if everything became data, how did that specifically change something as basic as making a phone call for the average person?
Well, that directly leads us to VoLTE, voice over LTE. Since the network was now this high-speed, efficient IP data pipe, voice calls could simply be delivered as another data service riding on top of it.
VoLTE, I definitely remember my phone switching to that.
Yeah, it became the standard way to make calls on 4G. And the sources highlight two really tangible benefits for users that came with VoLTE. First was call connection time. Remember that slight pause, sometimes several seconds on 3G, after you hit dial before the ringing started?
Oh yeah, that delay.
VoLTE drastically reduced that call setup time. Because it didn't need to establish a dedicated circuit path like the old system, it could connect calls much faster, almost instantly sometimes. It just started sending the voice data packets.
That definitely felt quicker. What was the other benefit?
Call quality. This was probably the more noticeable one for most people. Because voice was now running as data over a high-capacity network, carriers could use much more advanced audio codecs. Think of them like higher fidelity audio compression. This resulted in that crystal-clear HD voice quality.
Ah, HD voice. Yes, calls suddenly sounded so much richer, didn't they?
Absolutely. It was a really significant audible improvement over the often kind of muffled sound of standard 3G voice calls, much wider frequency range.
Faster connections, clearer calls, definitely noticeable upgrades. Okay, so we've got this faster, more efficient, all-data network. Thinking about what we actually did with all that new capability, the sources seem to pinpoint a specific killer application for 4G. What was it, and how did it really shift our media habits?
Well, 4G obviously enabled a whole range of things, but the material we looked at makes a very compelling case that high-definition video streaming on the go was arguably the single biggest standout killer app.
Mobile HD video makes sense.
Yeah, think about it. Before 4G, trying to reliably watch, say, a 720p or even 1080p video on your phone while you were out and about without it constantly stopping to buffer.
Yeah.
It was basically impossible unless you found a good Wi-Fi signal.
Totally. You just wouldn't even try, usually.
Right. But the combination of 4G's much higher speeds and that lower latency we talked about, that made streaming HD video from services like Netflix, YouTube, and later, platforms like TikTok, a smooth, buffer-free reality.
It really did change things overnight, almost.
It felt like it. This wasn't just a small improvement. The sources describe it as transformative. A completely untethered, high-quality video consumption from your living room or your Wi-Fi network. Suddenly, you could watch a movie on the train, catch up on shows during your lunch break, watch high-res clips anywhere. It truly made high-quality video mobile and fundamentally altered how, when, and where we consume media.
Yeah, the shift was massive. It feels like video became the default content online because of 4G. Now, beyond just watching videos, how did that speed and low latency impact other kinds of real-time mobile activities? Thinking about, like, gaming or communication apps.
Yeah, that low latency aspect was absolutely critical for anything needing a quick response. So for gaming, it was a game changer. Literally, it meant that responsive, real-time multiplayer online games, things like fast-paced shooters or MOBAs, weren't just possible on smartphones. They became incredibly popular.
Right, because the lag wasn't killing the experience anymore.
Yes, exactly. Before 4G, most popular mobile games were maybe turn-based puzzles or things that didn't rely heavily on instantaneous online interaction because 3G latency was just too high and unpredictable. LTE, as the sources put it, turned the smartphone into a legitimate and powerful gaming platform. Suddenly, you could play these complex, competitive online games anywhere.
The phone became a serious gaming device.
It really did. And then for communication services, think about apps like Skype, Apple's FaceTime, WhatsApp calling, and then later, Zoom and Microsoft Teams becoming ubiquitous. 4G's reliable high speed meant these voice and especially video calling apps became genuinely dependable over cellular data.
You didn't always have to hunt for Wi-Fi for a video call.
Precisely. You could have clear, stable video conversations, whether it was catching up with family or having a serious business meeting, from pretty much anywhere. It made those tools practical for everyday personal and professional communication, untethered from fixed locations.
It really did broaden the scope of what the phone was for, didn't it? Making it a tool for real-time interaction in so many ways. The sources also draw a strong link between 4G and enabling the mobile cloud revolution. How did 4G make accessing cloud services from our phones finally feel seamless?
That's another excellent point the material brings up. Cloud storage, things like Dropbox or Google Drive, and cloud-based productivity suites like Google Docs or Microsoft 365, they existed before 4G, of course.
Sure.
But trying to access large files or collaborate in real time on a document from your phone over a typical 3G connection was often slow, clunky, maybe unreliable. The sources describe 4G as providing the necessary fast enough mobile on-ramp to the cloud.
The on-ramp, I like that.
Yeah, with 4G speeds and reliability, suddenly you could seamlessly pull down large presentations from your cloud storage just before a meeting. You could genuinely collaborate with colleagues on a shared document in real time, right from your phone or tablet, without frustrating lag. You could use powerful cloud-dependent applications directly on your device and have them feel responsive.
So it made the cloud feel immediate, even on mobile.
Exactly. It essentially untethered not just communication, but actual productivity and data access from the traditional office desktop or the need for constant Wi-Fi. It was another major step towards being able to manage your work and life effectively from anywhere, primarily using your mobile device.
Okay, that makes sense. Now, something else that really exploded around the 4G era was the Internet of Things, IoT. We went from a few connected gadgets to, well, everything being connected. How did 4G LTE lay the groundwork for that massive IoT expansion?
It's true that some very low-power, low-data IoT devices could and still do use older or specialized networks. But for the massive and incredibly diverse ecosystem of connected devices that emerged, the sources make it clear that 4G LTE provided the critical network foundation.
What did 4G offer that was so essential for IoT?
It was really that combination of three key things:
Mhm.
reliability, security, and, very importantly, widespread high-speed coverage. You needed a network that was consistently available almost everywhere, that could handle significant amounts of data securely to connect this vast new range of devices.
Right, because IoT isn't just smart thermostats anymore.
Not at all. Think about connected cars. They need constant, reliable data streams for real-time navigation updates, remote diagnostics, emergency services, maybe streaming entertainment for passengers. That takes bandwidth and reliability. Or think about smart cities using sensors to monitor traffic flow, air quality, parking availability, all needing to reliably upload data.
Industrial uses too, I imagine.
Absolutely. Industrial equipment monitoring, predictive maintenance, remote control systems. These often require very reliable low-latency connections. And then, yes, the whole explosion in consumer IoT smart home security cameras, streaming video, smart appliances, wearables tracking health data.
Yeah.
4G provided that robust, high-speed, and importantly secure backbone that was necessary for the IoT to scale from niche ideas into the widespread phenomenon it is today.
So it wasn't just about making our phones faster. It was about creating a reliable network fabric for potentially billions of other devices to connect to as well.
Precisely. It built the capacity and the coverage needed.
Okay, stepping back even further now, looking at the big picture, what was the broader societal impact of 4G? How did it really cement this mobile-first world that the sources talk about us living in now?
This is where you see the truly profound, almost irreversible societal shifts. The sources don't mince words. They call 4G a catalyst for massive societal and economic change. And a key reason for that was how it changed our perception of internet access.
How so?
By delivering mobile data speeds that, for many common tasks like browsing, social media, email, even streaming standard video, often matched or sometimes even exceeded the home broadband speeds many people had access to at the time. 4G effectively erased the performance gap, or at least the perceived gap, between mobile internet and fixed-line internet for everyday use.
Right, the phone wasn't the slow option anymore.
Exactly. And the huge consequence of that, as the sources emphasize, was cementing the smartphone as the primary digital hub for vast numbers of people. For many, especially in developing nations, but also increasingly everywhere, the smartphone became the only computing device they needed or used regularly to access information, online services, banking, education, you name it. This massively accelerated the global shift towards what we now understand as a mobile-first digital society, where the default assumption is that services, information, and interactions should be easily accessible and perform well on a mobile device.
It really did flip the script, didn't it? From mobile being secondary to mobile being primary.
Fundamentally.
And that mobile-first shift, it didn't just change how we access existing things, it actually created entirely new types of economies, right? The sources talk about the on-demand sector and the creator economy. How did 4G's specific capabilities fuel those?
That's a crucial connection the materials make. 4G is identified as the critical engine for the on-demand economy as we know it. Think about services that absolutely depend on reliable, high-speed mobile data combined with accurate, real-time location information.
Like ride sharing.
Exactly. Ride-sharing like Uber and Lyft is the classic example. Or think about food and grocery delivery services, DoorDash, Skip the Dishes here in Canada, Instacart. These business models simply could not have flourished, certainly not at the scale they did, without 4G. They rely entirely on seamless, low-latency communication and constant location updates between customers, drivers, or shoppers, restaurants, and the central platform. 3G just wasn't reliable or fast enough for that complex, real-time coordination at scale.
It needed that instant, reliable connection everywhere.
Absolutely. And then simultaneously, you have the creator economy. Remember how we talked about HD video streaming being the killer app? Well, the flip side of that coin was content creation.
Uploading that content.
Precisely. Remember how painfully slow and failure-prone uploading even a short, decent quality video could be on 3G? 4G, as the sources put it, made it effortless by comparison. Suddenly, creators could stream live video in high quality directly from their phone from almost anywhere. They could shoot, edit, and upload high-resolution videos quickly and reliably while on the move.
Lowered the barrier to entry massively.
Hugely. This ease of mobile creation and sharing directly fueled the explosive growth of platforms built around user-generated video and live streaming, Instagram Reels, TikTok, Twitch, YouTube Shorts. It empowered a whole new generation of digital creators who could build audiences and even businesses primarily using their smartphones and the 4G network.
Wow. It's really striking when you connect the dots. So many industries and platforms we just take for granted now really have 4G baked into their DNA. Okay, last question then, bringing us right up to today, June 10th, 2025. 5G is obviously rolling out and getting a lot of attention, but what is the current role and the lasting legacy of 4G LTE, according to the source material?
It's a really important point. Even with all the focus on 5G expansion, the sources are absolutely clear. 4G LTE isn't going anywhere anytime soon. It remains the absolute workhorse network globally.
The workhorse, yeah.
It's the mature, incredibly reliable, and nearly ubiquitous high-speed network that provides essential connectivity for billions of people every single day, both around the world and right here in Canada. For vast areas and huge numbers of users, 4G is still the primary and often the only high-speed mobile data service available.
Yeah.
The sources describe it perfectly, I think, as the workhorse network upon which our current digital lives are built. It's the foundation.
So its legacy isn't just historical, it's ongoing.
Absolutely ongoing. Its ultimate legacy is multifaceted. First, it delivered on that initial promise of true high-speed mobile broadband, fundamentally changing user expectations. Second, it cemented the smartphone as the undisputed central hub of our digital existence, enabling this entire universe of mobile apps and services. And third, in doing all that, it made the mobile internet transition from being a convenience or a novelty to being utterly indispensable to modern life, work, and society.
Indispensable, that feels like the right word. It really is the bedrock, isn't it? Even as we talk about 5G and what comes next, it's kind of mind-blowing to think how much of our daily digital rhythm, streaming shows on the bus, jumping into an online game queue, collaborating on a work doc from a cafe, navigating across town using real-time traffic, ordering dinner with just a few taps.
Yeah, all those things.
So much of that is still fundamentally running on and totally reliant upon the incredible infrastructure and the technological leaps that 4G brought us. It makes you wonder, doesn't it? How much of your own digital life right now is still riding smoothly on those 4G highways that were built over the last decade? That's definitely something worth considering. Well, this has been fascinating. Thanks for diving deep with us today into the truly era-defining impact of 4G LTE.
My pleasure. It really did set the stage for the world we live in now.
It certainly did. And if you found this deep dive interesting and want more explorations into the tech that shapes our world, past, present, and future,
then we definitely invite you to subscribe to our channel, Tech AI and Beyond. We'll be back soon with another deep dive.